Okay, good evening to all. Welcome to my new playlist on ETABS. Okay, future will discuss about all the things about the ETABS software. The ETABS is an advanced risk tab. You will create the tall structures, earthquake analysis, response spectrum, and then so many things are in analyzing ETABS also. Okay, I will discuss about the things on how to create the different beams and different things in stack or ETABS also. Okay. Today is the first class for ETABS. Today we'll start the how to create the cantilever beam, then how to analyze the beam and how to take the shear force and the bending moment diagram for your cantilever beams. Okay. Today topic is how to analyze and take the shear force and bending moment diagram for your beam. For the reference, I take the book sum in bunch also. Okay. This is our question. The cantilever beam, the length is a 2 meter, carries the point load as shown the figure. This is our fixed end. This is one of the fixed end. Other end is a free. This is the total is a 2 meter. Is converted into 300 kilonewton, 500 kilonewton, and 800 newton also. Okay. This is the load. Then the how to create the same beam and load different types of point loads. Then how to create the shear force and bending moment diagram in ETABS for manual reference. Okay. So, okay, this is our ETABS 3D modeling software. It's created the all the things in ETABS. Okay. This is our first step. Go to file. I create a new models. Okay. I simply create a new model. Then go to this our setting. I go to simply build in with settings. Your first setting is a display unit. Our display is a metric SI, is the Indian standard. Our first setting is a display unit, our setting. The second setting is a seal section database. Our steel code is a Indian. Okay, simply select your steel section database. Then steel design. The steel design code is a IS 800. Okay, I was selected before you started your designing. You selected your steel codes and steel design code and concrete design code also. Our concrete design code is the IS 456 2000. So, okay, there's so many designs are there. Our first step is the IS 456 2000. This is our first basic setting for your model installations. Okay, first setting is a metric SI, then Indian, then IS 800 still, then click OK. This automatically it's created the all the things in meter. Then load will change the Newton also. I tell about how to change the units also. Okay. First of all, I created the duct slab, flat slab, and all the things also. You created the all the things. First of all, our question I created the member. Okay. First of all, I created the member. In our question, total is a 2 meter. Right? The total is a 2 meter. Is a even surface or uneven surface. Two methods are there. This is only one dimensional, right? This is only one dimensional. I simply created the beam only. Is a 2 meter. Is a x distance. Okay. I simply go to this is a x distance. Number of grids. Number of grids is a 2 point only. Starting is a 0 point. Ending with a 2 meter. This is a grid point. It's a 1 and 2. Starting is a 0, ending with 2 meters. Okay, ending with the 2 meter, totally two grid points. I simply go for x distance. I simply click this 2. The y is a single dimension, so I click this 0. Some error will be comes. Okay, then put the value as a 1. Is a no problem. Then x distance, the spacing of distance. Our x distance is a total distance. Is a 2. No y distance, so put 1. Okay, this is the simple method. Our grid point is a this is our grid point. This is our starting grid point. This is our ending grid point. The total is a 2 points in our x direction, and the spacing is a 2 meter only. Okay. Then this is our simple data. I simply this is not needed. You go for 2D or 3D structure. You only adjust your story structure also. I simply go to number of stories, I need a one story. I simply take this story height is a 3 meters. Okay. Let's briefly discuss about the 2D framed structure, how to create the story heights and others. This is only single dimension. So I simply go to X direction and then I created the spacing for X only. Then go to click OK. This is our main screen for your ETABS. These are the two windows are available. You same times you will be work for your 3D window also, 2D window also. Okay, these are two windows are available. These are the so many plans are there. This is the elevation view. This is plan view, elevation view. How to change your plan view, elevation view means this is our plan view. See this is our plan view. Set the plan view. I simply go for plan. This is my story one. I need the story one. This is our plan views. I change the elevation view nearby. I simply go for elevation. I click this. Okay. This automatically it's take the elevation view also. Okay. Then go to I need the another elevation. I simply click this one. Okay. So this automatically our base also grid will be created. Then go to plan one. I simply click this story one. Says automatically it's created the grid dimensions is automatically it will be selected. This is our elevation diagram. Simply select apply. Okay, this is our elevation. This is a only for plan view. Is a only plan view dimensions. Okay, simply click this plan view. Our first step is a you study the any subject like a question for beam design. You create the material for your beam and loads and supports and so many things. Okay, there's so many things for your beam. The first step is simply change the uh, applying our material. Okay, first of all I change the load weight into newton. Okay, I go to option display units. Okay, I simply go for display unit. This is structural units. This is section area, displacement area, force areas. Okay, I simply change the all the load. This is our force. I simply change my force areas. Okay, I chim one second. Yeah. Once again, simply select this our force unit. Simply go to this our force. All are in kilonewton or moment also Newton. Simply click this our force. I change into Newton. All are in Newton. I simply click this Newtons. Okay, I changes all the unit as a Newton. So the question will be given as a Newton also. Okay, I simply change the all the units change into newtons. Okay, see this automatically all the units modulus, stress, drift, displacement, structural dimensions and all the units are taken into units in newton. I change that all the things are easily converted into newton also. Simply click OK. Our second step is setting on unit is over. Okay, the setting on unit is over. Simply go to option display units. You will be change it. Then go to I ask them some questions. Okay, I ask some questions. You simply you design any beam. What are the conditions will be that you simply design your beam. The questions are first of all you apply the grade of concrete for your beam. Your first step is the grade of concrete for your beams. Okay, and the paint is not opening. Okay, our first step is the grade of concrete. Okay, first step is a grade of concrete, second step is a rebar, and the third one is the size of the beam, and fourth step is a load apply, and fifth step is a support. Then you will be finally analyze your beams. Okay, I close this window. I simply close this. I need the only single windows. Okay. Okay, I needed two windows. Simply go to add new window. This automatically add this new windows. Okay. Then go to plan view, click this story one. Okay, it says automatically it will be visible. Our first step is applying on the grade of concrete and rebar material. I put M20 grade of concrete and Fe 500 rebar. Okay, how to apply the M20 grade of concrete and Fe 500? Simply go to define options. Okay, simply go to define option, then go for materials. It's common to all 2D, 3D, all structure is a material option is a one. I simply go for material properties, then go to add new materials. Okay. Then go for add new material. The region is a Indian. Okay. You change into Indian material type. I need a concrete. Is a Indian is a M60 grades are available. I need a M20 grade. Okay. I need a M20 grade for my beam. Simply click OK. Then this is our grade of the unit weight of your grade and other Poisson ratio. So no problem. Do not changes any values. Okay. Simply click OK. So automatically it's created the M20 grade concrete. Then I need the rebar for my Fe 500. Then how to create same procedure? Go to define, go to material properties, add new material, then same procedure. Material type you go to change into rebars. Okay, rebar. Then Fe 500, Fe 550s are available. I need the Fe 500. I simply change into my rebar size is the Fe 500. Okay, this is our rebar material, the density volume of your steel rebar and other explosion models of velocity, then coefficient of thermal expansion, all the things will be given. Okay, simply click OK. I created my M20 grade of concrete and Fe 500 is the first step. Okay, this is our first step for your building beam. The second step is the applying on the property. First step is the grade of concrete and rebar will be created. Then next step is the property creations. Okay, section properties. How to create the section properties means go to define section properties. Okay, go to define section properties. Then go to this. You will be apply all the section properties also slab, depth, walls, all the things. I simply go for frame sections. Okay, this is a frame, it's a beam column, so I select the frame section, then go to add new properties. Okay, you will be create the steel properties and composite special properties also. I need the concrete beam. I simply go for concrete. Okay, I simply go for concrete. I simply take my beam size. My beam size is a 230 into approximately for 380. Okay, 380. Then go to material. I mean concrete material already I created M20s. Okay, the M20. Next one shape. So all the shapes are there. This is my concrete rectangular. Then go for your section type. This is just a name only 230 by 380. This is only for dimension. This is our width 230. Enter this is a 380. This automatically it will be changed 230 by 380 by section dimension. Then go to modify show modifier. This is the modifier rebar. This is a show modifier is the your moment of axis and then inertia force for 100%. I will be take that. Okay. Then some of the percentage also available. You go for tall percentage 16700. You refer that the percentage will be given. How to change this? Stiffness modification factors. Okay, I simply give that. Okay, then I go to apply my rebar for my beam. Go to modify show rebar. I select that beam only. Okay, I select that beam only. Then longitudinal bar. I need a HYSD 500. Same like that. Settlement bar also I need that HYSD 500. This is our cover distance. I simply enter 41. I tell about how to take the 41 for this cover distance also. I simply change it to beam. Then I change the longitudinal and the settlement. Then go for covers and etc. I simply click OK. Then OK. This is our second step also over. Our second step I simply created the beam size for my cantilever beam. Simply click OK. Our first step is the grade and material, and then second step is a steel created for your shapes, then material frame section. Then third step is the assign for your beam shape. Okay, how to assign your beam shape for your material, sizes for your material. Then go for draw options. Okay, then go for draw option. Then go to draw beams. Okay, then go to draw beams. Then go to quick draw beam option. Select your quick draw beams. To select the quick draw beams, automatically this type of dialog box will be open. Simply go to properties, select your beam sizes 230 by 300. Okay, 230 by 300. Then moment release. Your moment is a pinned support. Simply support is a pinned support. You go for continuous. Two option is there. You design a simply support. You will be provide this continuous. Then I provide the continuous also. You take this any moment for your conditions. Okay. Then go to next step, apply for my beams. Simply go to select this beam. Is this select this corner to this corner. Once again, I simply go for elevation. Just I simply change it to 1. Okay. Then click this. You simply apply the elevation portion only. Okay. You simply apply the beam section for elevation portion only. Simply go for elevation, then click 1. Okay. Then click 1. Okay. Automatically it's change the elevation portions. Okay. I apply my beam sizes for my beams. Okay, then give this escape. Then how to see the 3D view for my beam size? Simply go to extrude objects. Yeah, this set display options. Okay, set display option. Then go to extrude frames and extrude cells. Simply apply. See, this is our beam size 230 by 380. Simply go for set display option. Then change into extrude frames and extrude cells. Okay, this is a 2D frame. This is our 3D frame also. Then how to then third step also over. The first step go to define material properties. Second step is a frame section. Third step go for draw. I change into elevation. Then apply for my beam size. Then fourth step is a support. The fourth step is a how to apply the supports for your beams. Okay. First of all, this is a one corner. I select this one corner. This one corner only for fixed support. Other is a free. So I select this corner only. Then go to assign. Go to joint restrain. The restrain is a support option. Then go for restrain. Go to fixed support. Okay. Then go to fixed support. Apply. Okay. This is automatically it's apply the fixed support. This other support is a free. The other support is a free. So this is a cantilever ones. Okay. This is a cantilever one. This is a support is a free. This is our free also. Okay. Then our fourth step also over the first step material size and apply for your material. Then go to assign joint restraint. I apply my materials. Okay. The next step is a applying for your load. Okay. The next step is applying for your 300 kilonewton for 0.5 meter and 500 kilonewton and zero point 0.8 distance for your 800 kilonewton. How to apply the different distance for different load condition in ETABS. Okay, how to apply the different load condition for your conditions. Okay, first of all, select your beam. Then go to assigns, go to frame load. This is a point load. This is a UDL. This is our point loads. Okay, this is our point load. Dead load it's automatically it will be taken. Okay, dead load automatically it will be taken. I simply change this into live load. Dead load itself it is automatically it will be taken as a like a stat pro. I simply change into live load. Is a the stat pro will give the minus, but it's not need to put the minus. Is automatically it's a gravity. So its a value will be taken. Okay. This is the two methods, relative distance and absolute distance. Okay. The two methods are there. I tell about later. You simply change into absolute distance methods. Okay. Absolute distance method. Our first distance is a Our first distance is a zero point 0.5 is a 300 kilonewton. See, the distance is a zero point 0.5. Our load is a 300 kilonewtons. Okay. Next point. The next point is a total 500. 500 is a zero point 0.7. 500, you simply change it. Sorry, 500 zero point 0.7 means 1.2 distance. Okay, 1.2. The next load is the 800. 800 is a 2 meters. Okay, I simply change into 800. The last, sorry, this is a load. I simply change into 800. This is a 2 meters. Okay, this is a 2 meter. Simply click OK. Since automatically it's taken into this distance for your 300, 500 and 800. Okay, how to apply the load? Simply select this, go to assign, go to frame load, points load, then taken into absolute distance. Okay, relative distance is some difficult to make that. You go for absolute distance, you will be calculated. Okay, 300, 500, and the last one is a 800. Okay, now it's clear. The fifth step are over. I will apply for my material section, and then support, and then load will be applied. The next one is a load combination and analyze. Okay, then our next step is a load combination and analyze. Simply go for define, go to load patterns. Okay, load patterns, dead load is a one, self weight automatically it will be taken. This is our live load. Live load already I will be given. So, okay, this is our live load. I do not go for any combination. Okay, you will be need the combination. You go for load combinations. Okay, I do not need any combination. So I simply taken into load patterns is a dead load and live load only. I will be take that values. These values all come from live load. The final step is a analyze. Okay, then final step is a analyze. How to analyze this structure? Go to analyze, simply go to run analyze. Okay, run analyze. Before you analyze, you will be save your project. Okay, this is our procedure. I simply go to, I save this models. Okay, I save this model, then it will be analyzed. Yeah, see this your deflection and all the things. Once again, click this. I analyze this portion also. Go to analyze and run analyze. So okay, this two portion are there. I simply click this, unlock this. Okay, then I click this portion. Click this, analyze, run analyze. So okay, fine, no problem. These two are there. I simply click this. Then how to see the shear force and bending moment diagrams and values for this beams. Okay. Then go to display. Go to force stress diagrams. Okay. Displays. Go to force stress diagram. Then go to frame pair spandrels. Okay. Frame pair, simply click this frame here. I change into live load. Okay, my live load is the moment is 3 shear is 2 2. I simply change the shear is 2 2. This is my fill diagram. Yes, I need the fill diagram and the values also. Show the values. I simply click this apply. See, this is our value for this portion. This is a minus 600, 1600. This is for this values also. Our shear value is 1600 is the correct one. So it's automatically this value is a 1600. Then this portion, this corner is automatically the cantilever is converted into zero also. So okay, this cantilever is automatically it's converted into last portion is this portion is a automatically it will be zero. Yeah, this is our load diagram. Then see this our moment diagram for this area. This is our moment 1600. See this value as a little bit confusion. The next is our distance. This is a moment is a corner moment. The corner moment is a minus 800. You simply click this. Okay, this is your confusion means simply click this right click on your beam. See this automatically our distance is a 0. Then our minus value is a 1600. Then simply check it. This is our 1600. Then this point. This is the 300 kilonewton. Then go to zero point 0.5. Simply enter zero point 0.5. This automatically this is a zero point 0.5 value. Yeah. This is our shear value for this area zero point 0.5. It's a load for your shear value also. Shear value total will be calculated this medium minimum value. You minus this values. Okay. You minus this value 300 minus 1600. You automatically calculated the minus 300 1300. The next one, next values are will be take that's all the values. Simply see this is the last one. It's a minus 800. Now it's automatically it's take the minus 800. The next this one is a 1.2 meter. 1.2 meter total shear force is a 1600 minus 500. 1100. 1.2 meter is a 1500. 1.2 meter. Click this automatically. It's a 1.2 meter. Yeah, click this 1.2 meter is a 1300 also. Something little difference will be take this values and this values also. This is a 1300, this value is also 1300 in this value. The last one is a 800. So 800 is the half of the portions. This automatically it's converted the half of the portion for your area. 800, 1300, and then finally 1600. So in this portion 1300, this is the one, this is our 800, this portion also total 800. Then moment diagram, this is a moment value. I check that manual moment value for your building. This is our moment, this is our shear force value for this area. Then this is our moment value. MD is a 0. The first moment MA is a 2350 Newton per meter. This is automatically 2350 meter. The next moment value, the next distance of the moment value. Then check it on this next moment is a MB 1550. This is automatically this is the correct distance. You take this 1550 also. See this is the correct one. The next distance, next moment is a 640. In this corner you go for 1.2 is a 640. See this automatically you go for this 1.2. This automatically it's go for 1.2 is a 640 values. Okay, you simply go for 640. This is automatically how to check your bending moment values and shear force values in this based on your sum also. Okay, this is a method to creating your check your shear force and other methods. You click this some difficult, you will be simply right click on this, you create this moment values and shear and all the things also. This is show the maximum value. I need a scroll value means I simply click this scroll values, so automatically you will be take this on this areas. Okay, this is the values. You will be take the values for this shear force and bending moment values. Okay, now it's clear how to create the bending moment and shear force values. Okay, this is a method to take the bending moment and shear force values. Then how to create the reaction forces for your building. Go to display, go to same force stress, then go to support spring reactions. Okay, go to support spring reaction. This is my live load. FZ is a reaction. I simply click this apply. See, this is our load, this is our reaction load, this is the 0, this is our reaction load. So 1600. This is automatically our calculation or reactions and others for our bending moment and other values also. See, this is our bending moment values and then reaction values, all others BA remains, the all values are same. Okay, now it's clear how to create the bending moment, and this type of shear force values and all the values with the manual and ETABS. Okay, you simply doubt it, simply click this right clicks, sorry, select and right. You go to display, then go to posters, beam PS, moment, simply apply, then click this right clicks. You take this all the values for your shear force and bending moment and the reactions values. Then you check the deflection values also. Okay, you will be check the deflections values. This is a method to creating the cantilever beam for your manual, and then ETABS also you will check the result for correct this method. Then how to design your cantilever beam in ETABS? Then I first steps I will be apply all the materials, then analyze my shear force and bending moment, and then I go for design for my cantilever beam. Then how to design your beam? Simply go to design options. Okay, design option, go to concrete frame design, go to concrete design, then viewer design IS 456 to 2000, then you change the any particle size, simply click this OK, then go to concrete design, select your design group, all group, then add OK, then go to design concrete design, your any combination is there, you select that combination, no combination is no problem, then go to then start design check option. This automatically it's give the reinforcement for your cantilever beam. Simply right click this. It calculated the reinforcement summary, all the summary for your beam also. So this is our reinforcement summary for your beam. You simply take design, you will check that all the summaries. Then you need the detailing, go to detailing, then create the start detailing. Automatically it's created the detailing sheets for your ETABS in reinforcement also. You will be column numbers and all the details for your beams. Okay, now it's clear. This is the first class for how to design a cantilever compare with the manual calculations. Okay, this is a method to creating the simple cantilever beam with the shear force, bending moment, deflection, and concrete design also. We will future we will discuss the another some of continuous beam, and then to fixed support, simply supported beam. We will discuss the all the beams also. Then how to calculate the shear force and bending moment in easy method in ETABS. Okay. Once again, thank you for all. Thank you for all.